All right, this is a latent heat problem. So I have an ice cube that's at minus 20 C dropped into a container of water that's already at 0. And I want to know how much water freezes onto the ice. So what's going to happen is some of the heat from the water is going to get pulled out and go onto the ice, right? So the heat to freeze the water, right? How can I say this? Maybe that sounds a little weird. Okay, think about it this way. The heat needed to freeze the water, the Q to freeze the water, the H2O, is equal to the same amount that'll raise the temperature of the water from, it's going from negative 20 to 0. Negative 20 to 0, right? So the temperature of, raise the temperature of the water from negative 20 to 0, right? That the water that's around the ice cube, that ice cube, it's going to pull some of the heat out of the ice cube, right? But it's also going to freeze some of that because it's at 0 degrees C. So basically, the change in heat is equal to the mass of the ice times the specific heat times delta T for the ice, right? Which is equal to the water's mass times the latent heat of fusion, right? So this is the mass of the water, and that's what I'm trying to find, right? So here's my, I'll write this. Here's my equation. The ice is equal to the latent heat of the water. So the energy from the ice that causes it to raise the temperature is equal to the energy that the water gets pulled out of it to solidify as ice, right? So all I got to do is solve for MW, right? So the mass of the water is equal to the mass of the ice, that should be an I, not a 1, times C times delta T over the latent heat of fusion. And it gives you all this, right? So there's my specific heat of ice, that's C. The heat of fusion, that's this number right there. That's the latent heat of fusion, right? That's L sub F. My change in temperature is from negative 20 to 0, so delta T is 20. 50 grams of ice, that's my mass of the ice, and you can solve for the mass of the water. So just a latent heat problem, setting MC delta T equal to latent heat.